let's go to LeetCode 991, broken calculator. So we are giving a broken calculator which have two integer starter value. And you can choose two options, multiply the number by 2 or subtract 1 from the number. And given the start value and target return a minimal number of operations, you need to display target on calculator. So there is two options. One is multiply by 2 that will increase our number. Another is subtract by 1 that is will decrease our number. So the thing is that if the target is smaller than start, then we can only do decreasing operation, right? So we'll never call the multiple solutions. So so the thing is that if of course we can write the corner case if target is smaller than start, we just return start minus target. Here, let's consider the more general case, the target will be greater than start value. So there are two options. One is we are doing from the start to target, which is like expanding way, right? As we know, if target is greater than start, the optimal way is we do from the target to start. So target, well, if it is divisible by 2, we divide by 2. And if not, so we do reverse, that is, this is subtract, and that is plus, right? Plus 1. So we'll know this kind of target to start, it is some deterministic operations, right? So we know because the divide by 2 will always be optimal than plus 1, because this one will increase the number, this will always decreasing, right? Our target is greater than start, so we choose target divide by 2 will be our first options. So of course we can write a DFS for this question, right? So, but DFS it is still we do not need to consider, actually do not need to consider two conditions. That because the operations is deterministic. That is, we just check if it is um, divisible by 2. We just call the DFS divide by 2. And otherwise, just plus 1, right? Because plus 1 will get the number increase. Well, it's not optimal for our solution. So instead we use the DFS, we can just write a while loop, right? And because the operation is deterministic, once we reach the target, the start value, we return our result. It's not necessary to use memo either, right? Because for memo, that is the case if the target have several options, right? We don't know which one is optimal. But this one, we know divide by 2 will be the optimal solution. So we'll choose this one as first approaches. So let's write code for this. So we can have int operations equals 0, right? So what we do is while this kind of target is greater than start value. So we have two options. So if target multiplied by 2 equals 0, we'll always divide by 2 as the first option, just the target divided by 2, right? Else we have target plus 1. And we'll have ops should increase by 1, right? And when we jumping out of the while loop, the start will be greater equal than target. So we'll never use decrease operator anymore, right? So what we return ops plus start value minus target. So this will be our solution. The time complexity will be O log target. Space will be constant. And the Python code will be very similar. All right. Ops equals 0, while target is greater than start value. So if target mod 2 equals 0, so target will divide by equal to 2, right? Else target should plus equal to 1. Now our ops should increase, right? So in the end, we just return ops plus start value minus target.